The next important parameter block is the lens settings. We can either jump to them here or just select the lens that's attached to our footage, and its settings will appear right away. As I've already mentioned within 3DEqualizer, these are called lens parameters, but in reality they define both the camera and the lens. It's just a naming convention. Let's go top to bottom. Identifier. This is the name of the lens, and once again it's crucial to name them properly. If you have multiple lenses and multiple footage sources, you'll get lost switching between them, so it's best to name everything right away what camera it is and what lens it was shot with. Film back. This is the sensor size of the camera. Here you need to know which camera was used to shoot the footage. If you don't, ask your supervisor. And if you are the supervisor, then you already know. It's absolutely essential to know what camera was used. Well, actually the exact model isn't what matters most. What really matters is the sensor size and the focal length it was shot at. More precisely, what truly matters is the relationship between these two, because what we ultimately care about is the field of view. If you don't have any camera data at all, you can just guess one of the values and then match the other accordingly. In the end, what we're after is the angle of view, and that is calculated based on sensor size and focal length. So where do you get the sensor size if you don't have the exact specs but at least know what camera it was? The obvious answer? Look it up online, on Wikipedia, or even better at camdb.matchmovemachine.com. That site contains detailed specs on a huge number of cameras and sensors. You just search for the model either by name or by brand, and you'll find its sensor size. So for example, if your shot was filmed on an Arri Alexa Mini and it was recorded in 4K, then your sensor size would be 26.4 by 14.85 millimeters. And right away, you might get a small note. The frame size doesn't match the official camera specs. The width of the frame is the same, but the height is different. Why does that happen? Because very often in post-production, you get the image with a letterbox with the top and bottom cropped. In general, you should always track the original footage. Work only with the source file. It's bad practice to first send it through compositing or editing, apply transformations, and then send it for tracking. That's a big no. If the shot was transformed during conform or editing, especially non-uniformly scaled, then you can't use the real camera parameters anymore, and you'll have to rebuild them manually, and that's a huge headache. So always track the original footage, or at least a phase of it, but never a transformed version. Now what if the top and bottom of your image were cropped? Then you simply need to specify the correct sensor width. Over on the right, in the film back panel, there are fields for the sensor size. But right now, you can't change the width because it's set to passive mode. How does that work? Passive mode means the parameter is calculated automatically based on other values like film aspect and pixel aspect. But if you want to start with a specific sensor width, you'll need to change the mode from passive to fixed. There's also an adjust mode, but we'll cover adjustments in a later section. So choose fixed and manually enter the sensor width. Let's say the width is 26.4 millimeters. Note that in 3DEqualizer, it's measured in centimeters. So 26.4 millimeters means 2.64 centimeters. That's a bit inconvenient since sensor sizes are usually listed in millimeters, but Equalizer uses centimeters by default. You can change this. Go to Options, Preferences, and from there you can also fine-tune some important interface settings. Transparency, window opacity, helpful when full screen, brightness, UI brightness, text size, background color, viewer background. That's all just to make your workflow more convenient. Always call up menu. This setting ensures that when you open a drop-down menu in Equalizer and select something, the submenu stays expanded next time. For example, File, Export. Next time this export menu will already be open. That's useful when you often use the same functions. Autosave window layout. The program remembers how your windows were arranged last time and restores that layout on the next launch. Super handy if you have a familiar workspace setup. Default parameter settings. Then we have a few key default settings. Default film back size. If you often track with the same camera, set its film back here. Default FPS gamma, soft clip. Likewise, if you know the correct values, set them in advance. Regular units. This controls the unit system for 3D space. If you're tracking large-scale scenes, choose meters. By default, it's centimeters, ideal for interior and street scenes. For macro shots, consider switching to millimeters. Film back units. This defines the unit used for sensor size. By default, centimeters, but it's better to switch to millimeters. 26.4 millimeters will appear as is, instead of 2.64 centimeters. Focal length unit. Focal length is always in millimeters, which is correct. For example, 30 millimeters. Focus distance unit. Focus distance equals how far the subject is from the camera. Centimeters are best here, especially for metric users. Cache settings. image cache size, how much RAM can be used for caching. For example, 50% of your available memory. Image cache compression, whether to compress cached images, and at what quality. Store compression file. Where to store the cache? In the image sequence folder, in the project folder, in a custom folder, you specify. Let me show you exactly what that means. Right now, if we try to play back the video, you'll notice it runs very slowly because EXR files are heavy and they take time to load frame by frame. To fix this, we can pre-cache the sequence. Go to Playback, Export Buffer Compression File. Whenever you load a new image sequence, especially heavy formats like EXR, the first thing you should do is export this buffer compression. Just hit export and the sequence will be pre-cached for playback. Next to your image sequence, in the same folder, you'll see a new file appear that's the buffer compression file. Once this file is created, playback becomes extremely fast, even for heavy sequences like EXR. Also, if you load a sequence and there's already a buffer compression file saved, 3DE will usually offer to load it automatically. If it doesn't, you can always load it manually via playback, import buffer compression file. You can change its location in the preferences. Network calculation refers to everything related to adjust parameters, that is, automated optimization of values. When you're adjusting a lot of parameters at once, it can become a very heavy task computationally. In these cases, you can connect multiple machines over a network and distribute the calculations across them to make the process faster. This section contains the network calculation settings. Everything below that deals with system-level settings like enabling the use of all CPU cores or allowing 3DE to use all available RAM. So let's continue where we left off with the sensor size setup. We've already entered the correct sensor width, but now we see that the sensor height is clearly wrong because the image looks visibly stretched. We do know that the pixel aspect ratio equals 1, which means our pixels are square. Change the mode to fixed. Set pixel aspect ratio equals 1. After that, the software will automatically switch film back height to passive mode. As a result, the sensor becomes proportionally accurate. Alright, so we set the sensor size and specify the focal length. It's absolutely essential to know which lens was used. In this case, it's a fixed lens, 50mm. The film aspect parameter is in passive mode. Most of the time, you don't need to change it. Lens center, offset X and Y. What does it mean? This applies to cases where the optical center of the lens does not match the center of the image frame. The most typical example is scans from film stock, where there might be an audio track running along one edge. In that case, the lens center is shifted. This can also occur if the shot has undergone any transformations or if anamorphic lenses were used. In most cases, when working with spherical lenses and unaltered footage, the lens center offset will be 0. Next, we have angle of view, the field of view. These parameters are also derived from the values you've already set. If the film back height is calculated automatically, as in our case based on the film back width and pixel aspect ratio, then the angle of view is also computed automatically based on the sensor width or height and the focal length. But all of this will also be set automatically as long as you know at least some of the parameters like we do now. You can enter the angle of view manually. If you happen to know it, that's totally fine. Pixel aspect depends on the optics used. If it's an anamorphic lens, then pixel aspect not equal to 1. If it's a regular spherical lens, then pixel aspect equals 1. We will be working with anamorphic footage and we'll look at a case where pixel aspect not equal to 1. A common question is, how should you track anamorphic material? Should you unsqueeze it before tracking or load it in its original squeezed form? And the answer is yes, you should load and track the squeezed anamorphic footage. We'll come back to this later in more detail. Focus distance is the distance from the camera to the object the lens is focused on. Often, a visual effect called lens breathing is present in the shot. When you change the focus distance, the field of view slightly changes. The image appears to zoom in or out a bit, as if the lens is breathing. This affects tracking too. If you're compositing graphics into such a shot, lens breathing must be taken into account so the compositor doesn't have to manually chase and compensate for the motion. If the shot doesn't have drastic focus shifts, you can simply enter the main focus distance and track with that just fine. You can manually adjust the focus distance, either by getting accurate data from the supervisor or the camera report, or if there's an object clearly in focus in the frame, you can visually estimate the distance from the camera to that object or even calculate it manually. Nothing stops you from doing that. Once you have the value, you can input the focus distance directly here in the lens parameters. Next comes the lens distortion group, which we'll return to in detail when we talk about using a distortion grid. But for now, here's a quick overview. Lens distortion model refers to the type of lens distortion model used for the shot. 3DEqualizer offers several options. Radial standard degree 4. This is the default radial distortion model in 3DEqualizer 4. It's the most commonly used. Anamorphic standard degree 4, used when the shot was captured with an anamorphic lens. Classic LD model. This is the legacy distortion model carried over from earlier versions of 3DE. Despite being older, it still performs well and has a big advantage. Its parameters are straightforward, there aren't too many of them. And you can tweak them manually with a clear understanding of what each one does. In contrast, the newer models tend to have more parameters that can be less intuitive. If you're planning to manually adjust the lens parameters, the classic LD model is a great starting point, as long as the lens isn't anamorphic. Radial fisheye degree 8 is the distortion model designed for ultra-wide angle lenses. You should use this model if your lens has an extremely wide field of view, where standard distortion models fail to deliver accurate results. In radial fisheye degree 8, focal length becomes one of the distortion parameters. It makes the model less universal, but more accurate for fisheye-specific use cases. Right, it's currently hidden because we've set a fixed horizontal angle of view here. If I set this field to fixed and also set horizontal angle of view to fixed, then the horizontal angle of view will reappear. And with the fisheye distortion model selected, the focal length becomes one of the lens distortion parameters. In all other distortion models, focal length does not affect the distortion. It only affects the field of view. And there's one more distortion model specifically for anamorphic lenses, but more advanced, with a more detailed distortion model. It's essentially the same as anamorphic standard degree 4, just with more parameters for finer control. We'll go deeper into the differences between all these distortion models when we talk about distortion grid, but for now just remember this. The distortion model is chosen based on the type of lens the footage was shot with. Which once again brings us to the importance of on-set supervision. If you're a supervisor, there are things you absolutely must know and capture on set. What camera is being used to shoot the shot? What is the focus distance during the shot? What lens is being used to shoot it? If the focal length is not fixed, what is the range of zoom throughout the shot? What type of lens is it? Spherical or anamorphic? Ideally, know the full lens model. It's essential to shoot distortion grids, so lens distortion can be measured and corrected accurately later. And if the camera is moving, it's very helpful to know the exact height of the camera above ground. All of this ties back into previous settings, the camera movement type, constraints, and so on. And the deeper you get into match moving, the more you realize how vital on-set data is for the post-production workflow. So welcome aboard.